And so we are solving the middle of an elastic collision problem. We have momentum before, we have momentum after, and because during an elastic collision, the impulse is equal and opposite on both carts, momentum is conserved throughout this elastic collision. So here's the problem. A 2 kilogram cart moving at 2 meters a second approaches a 1 kilogram cart moving at -4 meters a second. And so they're moving in opposite directions. Theoretically, they have different masses. They meet and compress a spring. It's a perfectly elastic collision. In other words, all of the energy remains in the system. It's just going to be stored as elastic potential energy in the spring in the middle of the collision. At some point, cart 1 is going 1 meter per second. And so somewhere during this compression, cart 1 takes on a speed of 1 meter per second. How much energy is stored in the spring? And so it's fairly trivial to figure out what the momentum is before. Fortunately, it all adds up to 1 in this case. Or sorry, that's a 0. It all adds up to 0 in this case, which just makes it handy. We know that momentum is conserved throughout the entire collision. So during the compression of the spring, it's also 0. And after, it's also 0. Kinetic energy gets transferred from the carts into the spring and then back to the carts. And so initially, this is going to be 0 joules. And after, this is going to be 0 joules. But sometime in the middle, the elastic potential energy is no longer going to be 0, but all of the energy will still need to add up to 12 joules. Okay. The first trick is going to be finding out how much momentum cart 2 has so we can figure out how much kinetic energy cart 2 has. We can also find the kinetic energy of cart 1 because we're given the mass and the velocity. We know that it's all going to add up to 12, and so that will tell us the elastic potential energy that's stored in the spring. Okay, so first things first, let's find out what the momentum of cart 1 is. So during this compression, the momentum of cart 1, which is 2 kilograms, now it's moving 1 meter per second, is 2 kilograms meters per second. Okay. That means that cart 2 must have a momentum of -2 kilograms meters per second for everything to add up to 0. Okay, let's quickly calculate the kinetic energy of cart 1. Cart 1 is 2 kilograms. It's moving at 1 meter per second. 1/2 times 2 times 1 squared is 1 joule. And so the energy of cart 1 is 1 joule during the collision. Cart 2 is moving at -2 kilogram. Cart 2's momentum is -2 kilograms meters per second, and cart 2 is 1 kilogram, and so the velocity at this point is going to be 2 meters per second. And the kinetic energy of cart 2, we can calculate 1/2 times 1 times v squared. And so 1/2 times 1 times -2 squared is 2 joules. And so now we know that cart 2 has an energy of 2 joules. And because everything has to add up to 12, we know that there are 9 joules of elastic potential energy stored in our spring. From there, we could go on and say if the spring is so compressed so far, what's the spring constant, all that sort of thing. But this tells us how much elastic potential energy is stored in the spring. So once again, the key is momentum is conserved throughout the collision. Energy disappears from kinetic energy into elastic potential energy and then is released back out as kinetic energy.